right, today we're going to look at graphing some rationals, figuring out a horizontal asymptote, vertical asymptote, and kind of writing equations from our rules of transformations. Okay, so the first thing we need to understand, though, is we need to understand, what the two parent functions look like. So the first parent function we're going to look at is y equals 1 divided by x. Okay, and I'm going to use Desmos to help us out with this. So we're going to fill out the table, and then we're going to draw the graph by hand. A lot of times we won't have to do that just because we do have access to Desmos as a resource. So y equals 1 over x. This is its graph. It's a funky looking graph. It looks like it has two parts, but this is still constitutes as one graph from this one equation. Okay. When I have a rational function like this, I also like to try to put in my asymptotes. And so I'm going to change those to red and make sure they're always a dotted line. So anytime I'm working with a function like this, that's what I kind of do. I always put in x equals 0, y equals 0. That way I can just kind of slide and move this around to find that VA and HA, okay? So this is the parent function. I need some points to fill out that table. So I just hit the cog, I go to the table, and now I have some values, okay? So so instead of -2, I need -10, so I just change that, and it gives me that value. I also need 0.5, so I will enter in a point, so -0.5 right there, and I'm just looking at this again from the table that it provided. I'll change that to a 10. Okay, so this is what my table looks like on the Explorer. So I'm just going to enter these values in for that table. So right here at -10, we had -0.1, -1, and -1, -0.5, and -2. At 0, it was undefined. Okay, I'm just going to abbreviate. At 0.5, it was 2. At 1, it was 1. And at 10, it was 0.1. Okay, so those were the values that Desmos calculated for me, right? And so now I need to transfer these over here. Okay, and whenever I'm drawing a graph with this, the first thing I want to do really is I want to be able to draw the vertical asymptote. So the VA, I'm doing that right here in green, and also the HA, the horizontal asymptote. So those were my dotted lines in Desmos. Okay, and so when I look at this, I just ask myself, hey, where does it get vertical, my graph? And that's my vertical asymptote. And then I ask the same thing, the horizontal, where does it get horizontal or flat? That's my horizontal asymptote. Okay, and so that's kind of how I find those, and that's kind of my guide for whenever I graph this by hand. Okay, so now I'm going to graph a few points. So I know that I have a point at 0.5 and 2, at 1, 1, and then about 10 and 0.1. So this part of the graph, kind of looks like that. Okay, and then I have a point at -0.5, -2, -1, -1, and -10, 1. Sorry, a little hard to draw on my computer. But that's what my graph looks like. So this is the parent function of a rational equation. Okay, and so we kind of talked about the horizontal asymptote and vertical asymptote. So the vertical asymptote, if we look at this where it goes vertical, this green line, this vertical line intersects the x-axis at 0. So we're going to say the vertical asymptote is x equals 0. And then the horizontal asymptote is right here. It intersects the y-axis at 0. So we say y equals 0. So these two have to be an equation. It's got to be y equals 0, x equals 0. Okay, so the vertical will always be the one with the x. Horizontal will always be the one with the y. Okay, then we look at domain and range. So I look at how far left and right does this go. Okay, so this is what I kind of see in my head, right? This goes over here left, right, to way over here right. And these two have an arrow at the end, so this approaches negative infinity to positive infinity. So the domain is all reals with the exception of one value, okay? And that's the vertical asymptote. So it cannot be 0 because this graph never gets to 0. So it says right here, this question, what can x not be? It can't be 0. Okay, so how do I write that in the domain? I simply put x, and I put my equal sign, and I put a mark through it, a line through it. That just means x cannot be equal to 0. So my domain is all real numbers. X cannot be equal to 0. So it's really just saying, hey, every number except for 0. All right. And so then now I look at the range. And again, I say, okay, how low does this go? Down here, to how high it goes up here. Again, these have arrows. So this continues to negative infinity. Up here, it goes to positive infinity. So again, we have all real numbers. Okay, and then what can y not be? Y cannot be this horizontal asymptote. So y cannot be 0 as well. Okay, and so then I say y cannot be equal to 0. Okay, and I get this from my HA and VA, right? X can't be the 0 and y can't be the 0. Okay, and then the only other thing we talk about is in behavior. If you see that it says in behavior, we're just looking at left to right. Okay, so basically the in behavior is going to tell us the horizontal asymptote, the HA is what we call it. Okay, and so what I do is I just ask myself, where does this graph, what number does it approach as I go to the left? Okay, and you can see it gets closer and closer to my horizontal asymptote. So it gets closer and closer to this value, which is 0. Okay, and then if I go right, you know, this part of the graph gets closer and closer to that same number. So it should end up being the exact same number, which is just the HA. So in this parent function, the in behavior, we say approaches 0. Okay, that won't always be 0 though. But again, this is one of the parent functions we're looking at. So all graphs that look like this will come from this parent function. Okay. Then we have another parent function, which is right over here. This time we have y equals 1 over x squared. So now the only difference is this one has a square. Okay, so again, same concept. I'm going to put that into Desmos. Y equals 1 divided by x squared. I'm going to go ahead and put x equals 0, y equals 0, and then I like to change the colors here. So I'm going to make this blue, these two red and dotted. So this is a good place to start every time you put in an equation now. Okay, going ahead and putting x equals 0 and y equals 0. I need some points. So again, I need -10. I need -1, -0.5, 0.5, and 10. Okay, so then there are my points. And so this is what my graph looks like. Okay, again, my vertical asymptote right here is still x equals 0 because it intersects the x-axis at 0. My horizontal is y equals 0 because it intersects the y at 0. So I know a lot of information just based off of this graph, right? So filling in here is 0.01, 1, 4, again undefined, 4, 1.01. Okay, so how do I graph that? Again, I start with my x and y intercepts, which really, or sorry, not my x and y intercepts, my VA and HA. So this is x equals 0 still, y equals 0. That didn't change, right? So if I went ahead and drew those two lines, here's my VA, and here is my HA. Okay, and now that helps me kind of guide these points. Okay, so let's see here. I have 0.5 and 4, 1 and 1 there, and then 10 and like really close to 0. So I have like this little curve right here, and I have like basically a mirror image on the other side. All right, and so that's the main difference between this parent function and the other one. Okay, so if we notice, go back up here, this one, the two parts are kind of in opposite corners, so they're going to be there or here. I'll summarize that here in just a second. And here, they're either going to be in the top two or they'll be in the bottom two. Okay, and so talking about domain and range. Okay, so what can x not be? 0. Y cannot be 0, right? Kind of as well. But if we look at this, okay, the domain doesn't change. All real numbers, x cannot be equal to 0. But the range here is from 0, because this is the low point now, to infinity. So 0 to infinity. So technically, the range we can write as two ways. All numbers greater than 0, or we can write it in interval notation from 0 to infinity. And again, we use parentheses because it won't ever equal those two values. So you can write it either or, right? And then in behavior again, remember in behavior is just our HA. So if we know our HA, we should know the in behavior. So this approaches 0. Okay, because as I go left, it gets closer to 0. If I go right, it gets closer to 0. Okay, and so those are our two parent functions. Okay, so today we're going to write equations that are either has a square, 1 over x squared, or we're going to have 1 over x. Okay, so let me summarize this for us. So if the parent function is y equals 1 over x, then as a transformation, our job is going to be to fill in these values: A, B, C, and D. Okay, now remember, the B value, like we very rarely use. Okay, so really I want you to concentrate on A, C, and D. Okay, and so this is the first parent function. Okay, just 1 over x. The second parent function, right, that we look at is y equals 1 over x squared. So now they're side by side. You can see the difference. It's just the squared. Okay, as a transformation, we have y equals, and then what we're going to have, the only difference is that squared, and now I still need to adjust A, B, C, and D. Okay, so now it's just a little different right here. You're going to have the squared right here. Okay, so we need to identify which parent function it comes from, each graph, and then we need to talk about this stuff. Okay, now We'll refer back to this page here in just a second. All right. So that brings us to our notes right here. Okay. So our notes, a few things we're going to always look at are domain range, vertical asymptote, horizontal asymptote. So I'm going to do 1 and 2 first, and then we'll kind of summarize some things here in just a second, okay? So let's look at number 1 right here. All right, so again, this is 1 over x, and then it has a plus 5 here. So if we're talking about transformations, again, I'll pull this up. Here are my transformation rules. Okay, so if you need to, this is important information. So it tells you what A does, B does, C does, and D does. So here we're dealing with 1 over x as the parent function, and we had plus 5 out here to the right, right? So if we look at that, plus 5. So that's the D value. 5 is the D value. So we come here, plus D means we shift up. So that's what we're going to talk about. I know that this graph shifts up 5 units from the parent function, right? So we're going to look at Desmos, right? Here is the one that had the parent function of 1 over x. Okay, and I'm going to go ahead and put my new equation, y equals 1 divided by x plus 5. Okay, and you can kind of see from the light blue to the dark blue, it did in fact shift up, right? And so now all I care about is this dark blue or purple line. Okay, so it shifted up, and if I need points for this, I can adjust my points. Before I get a table of values though, notice the vertical asymptote is good. It's still x equals 0, but the horizontal asymptote is no longer at y equals 0. So I take this y value and I just slide it to where I need it. So where does it get horizontal? It gets horizontal right there at y equals 5. So our HA has been adjusted now. Okay, so then I can come down here and fill that in. The VA did not change. It was still x equals 0. The HA changed to y equals 5, okay? So y equals 5. So then I can really do the domain and range right now. All reals, x cannot be equal to 0. Range, all reals, y cannot be equal to 5. Okay, again, I get these values from my HA and VA. And then now I'm going to draw in my graph. So the VA was still x equals 0, which is there, but then the HA was up here at y equals 5. Okay, so there's my VA and HA. And then now I can use Desmos. Click there, get the cog, go to a table, and really I just need a few points. So -1, 4 is good. So I'll come back over here and do -1, 4. Okay, and really I just need like 1 point because I know kind of what it should look like, right? And then I get 1 on the other side of undefined. 1, +6. 1, +6. And I know that my graph looks like that. And so I use these, the HA and the VA as a guide to draw that curve. Okay, and so here's my graph. Okay, and so I'm done with number 1. All right, so then let's move on to number 2. This time, if I'm looking at this equation, I notice the C value right here and the D value are something different. So I have x minus 2. So if I go to my transformations, x minus C means I shift right. So I know I'm going to go right 2. And then a +1 for the D value right here means I go up 1. So again, that's from my parent function. So I go back to my Desmos. Again, I can X out of that one. Here's my parent function. right? And then I put in my new equation, y equals 1 divided by x minus 2. Okay, you can see that that shifted to the right. And then when I do plus 1, now it also shifted up. So right 1 and up 2. You can see those points, right? So now we can get a table of values if we need to. Okay, and here's undefined. So if I need something else on the other side, there's a point on that side as well. So if you notice the undefined at 2, okay, one thing I needed to do, sorry, before I get ahead of myself, I need to adjust the VA and the HA. So now the VA looks like it gets vertical right there, which is a value of 2, okay. So x is equal to 2, and then the y is down here at y equals 1. So that's my new VA, my new HA. So that's why I always start with these and I keep them there so that I can slide them around, right? I want you to notice something. The VA is x equals 2. Every time it says undefined, right? Here's 2 and it says undefined. When it says undefined or error, that tells me that that's my VA, okay? So just keep that in mind. So my VA for this is x equals 2. My HA is y equals 1. Okay, so if I wanted to, I could go automatically into my domain. All reals, x cannot equal 2. I can automatically do my range. All reals, y cannot equal 1. Okay, and so when I'm drawing this, again, my VA is at 2. So here's my VA. My HA is at y equals 1. So there's my HA. And then I can now draw my graph, okay, based on some of those points. I have 1, 0, 1, 0, and then I can kind of draw that portion. And I had 3, 2, I believe. Let me just double check, 3, 2, yep. And so there's my graph. Okay, so this is what I want to summarize right here. If you notice, the C value here was a -2. That tells me, so x minus 2 tells me I move right 2. Look at what my VA was. It was a +2. Okay, the D value here was a +1. My HA is +1. Y equals 1. If I go back to number 1, there was no C value, so that means the value of C is 0. My VA was x equals 0. The value of D was +5. My HA was y equals +5. Okay, so this is what I want you guys to know. If we have y equals, and then we have everything written as a transformation, I want you guys to know that the C value is just the VA, vertical asymptote. The D value is the HA, the horizontal asymptote. Okay, and that does not change for the other parent function that has x squared. This is still the VA, VA, and this is still the HA. Okay, so keep that in mind as we work things today. So now, okay, I should be able to look at number 3, the equation, and say, okay, what is the C value? What is the D value? Here, there is no C value. So that should tell me that the VA, which is x equals, is 0, right? And we'll check it. There is no D value written out here. So that means the HA is also 0 because it's not written there, right? So I should be able to look at the equation now and be able to automatically tell the VA and the HA. Okay, so this one, the parent function is down here with the squared because x is squared. So I'm going to plug this into Desmos. So notice here's my original parent function of 1 over x squared. And then I go y equals 2 divided by x squared. Okay, so now we're looking at this graph. Okay, so from my parent function to this new graph, okay, what transformation occurred? Well, look what happened. The a value is what's different. A is now greater than 1 because it's a 2. So we have a vertical stretch by 2. So that's the first thing. So we have a vertical stretch by 2 because of that number right there. Okay. And then now, again, I just go ahead and start drawing. Here's my VA, HA, and then if I grab some points, again, I just grab a table. You know, these points, really those 2 points are probably good enough. So -1, 2. And 1, 2, and then there was something about 2, and all right, so -2, and it comes really down here, right? And so there's my curve. All right. And so now the domain stays the same. All reals, x cannot equal 0. The range, however, is different because we come from a new parent function. So this goes from 0 to infinity. Again, y is greater than 0, or you can say 0 to infinity that way. Okay. And then for number 4, even though this is written a little bit different, I'm going to rearrange it. Y equals -2 over x plus 3. Well, now we're looking at the d value here and a c value right there. So if I'm just looking at the equation, there is no c value. So c value is 0. That tells me the VA. If I look at the d value, that's 3. That should tell me the HA. Okay, so I should be able to know that my VA is going to be here at x equals 0. My HA should be there. Okay, and I'll check it whenever I plug it into Desmos. So again, this is the parent function 1 over x because it's just x down here. So I'm going to plug this in. Okay, and before I do want to talk about the transformations. The top number, which is a, is negative. So a is negative, reflection over the x-axis. So we have a reflection over the x-axis. Then we look at the absolute value of that value. So it's just 2, right? So the absolute value of 2 is greater than 1. So that's a vertical stretch as well. By 2. And then the d value is plus 3. So I come over here, d value plus, shift up 3. So up 3 units. All right. And so those are the transformations that occurred from the parent function. So let's see what that looks like. I can plug in either or. I'm going to plug in this original equation. So I get rid of that one. So again, y equals 3 plus -2 divided by x. And so here is my graph. I need to adjust my VA. It goes to 0, so we were right in that aspect. And then my HA should be at 3. And it looks like we were right in that aspect as well. So there's my VA and HA. Okay. Table of values. negative 1, 5, negative 1, 5, which is there, and 1, 1, which is there. And so now my graph looks like that. Still in opposite quadrants, but remember this was reflected, so instead of being here, they're there now. Okay, and so now my domain and range, all reals, x cannot be equal to 0, all reals, y cannot be equal to 3. All right, and then number 5 I want to talk about. Right now, this is the tricky part, okay? You see this as the C value, right? There is no D value out here, so the D value, nothing. So the D value, y equals 0. Okay, but the H, or the C value, you would think that the this would tell us what we need to tell you. This would move left, right, left, one place, but we have to adjust this because of that negative in front of the x. So this little negative in front of the x is messing things up. So watch what happens, right? If I go y equals 1 divided by negative x plus 1, sorry, it was 3 over, then that one didn't shift left. So why is that, right? Why did it not shift left when we have a plus 1? Well, it's because of this negative right here. Okay, so technically, I would have to factor out this negative before I could say, hey, this is what's going to happen, right? So this is the C value. So now we have x minus 1. So this says it's going to shift right 1. So my VA is x equals a positive 1. Okay, and if you struggle with this, again, when I plug this equation into Desmos, you can see that my VA shifted over to a positive 1. Okay, and now my HA looks like it's 0. Okay, so always check with Desmos. And then here we go. Let's graph it. So VA is at x equals 1. HA is at y equals 0. And then I need a point. So we have 0, 3, and 2, negative 3. So 0, 3, 0, 3, 2, negative 3, and there is my graph. Okay, we need to talk about transformations here. I'm going to use this one over here. The A value is 3, so that tells me vertical stretch. Right? The B value right here is negative. So now when the B value is negative, it's a reflection over the y-axis. So a reflection over the y-axis. And then here we have x minus 1, so that tells us that it went right 1 unit. And then to fill out the domain should be easy. Range should be easy now. Okay. All right, so that's all taking an equation, figuring out the transformations, and then the other attributes of the HAVA domain and range. Okay, on the back side, this is what's going to be difficult for you guys. Now, our job is really to find the equation, the VA, HA, the domain, and the range. We're going to do that for all of these problems, but we're given different things, right? So here we're given a graph. Okay, so what can I gather from this graph? So it tells me a point, but the very first thing I want to do is from a graph, I can usually see the VA and HA. That's what's going to help me quite a bit, because remember, the VA is basically the C value and the HA is basically the D value, right? So that's the first thing I'm going to do. I'm going to say, okay, my VA, where does it go? Where does it get vertical? Right here. It looks like it gets vertical right through there, and that's at x equals -4. So the VA is x equals -4. Then I ask myself, okay, where's my HA? Well, here's my HA. Okay, and that looks like it goes through y equals 1. So my HA is y equals a +1. So in my equation, right, I know that I am dealing with, remember we talked about this, I'm dealing with y equals 1 over x, because this is what my graph should look like. So if I'm dealing with this, my graph should look like that in opposite quadrants, or like that. They're still in opposite quadrants, right? So I know I'm dealing with this as a parent function. So I just need to find the A, C, and D value. If I'm dealing with this one over here, I know that it's going to be both in the top 2 quadrants or the bottom 2 quadrants. Okay, so this one, examples like this. So I know that my equation is going to be y equals A over x minus c plus d. Okay, well, I need to fill in some things, right? So I should know the c value right here. The c value is a -4, so it's x minus a -4, which becomes a +4. And then I know the d value, which is 1. So I just erase that d, and I put a 1 right there. So I've got most of my equation done. I just need to figure out the a value, okay? So I'm going to do it 2 ways. I'm going to do it algebraically, okay? So if I'm looking for the a value and I have all my other stuff plugged in, I'm going to use a point, okay? Any point. In this case, it just gives me this point. And I'm going to substitute that in for y and x. So if I go 0 is equal to a over -3 plus 4 plus 1. This is solving it algebraically, right? Then I just solved this for a. I need to move that 1 over, so I subtract a 1 to both sides. Okay, that leaves me with -1 is equal to a over, and then I just calculate that. -3 plus 4 is 1. Well, a divided by 1 is simply just a. So a is equal to -1. So now knowing that, I come back up here and I adjust my a value. So I can do that algebraically. If that doesn't make sense, okay, I can always use Desmos and guess and check for the a value. So I start with basically my parent function, right? Okay, so y equals 1 divided by x, and then I adjust. I knew that this was a +4. I know this is a +1. Okay, and then I started with that, and I know it goes through the point -3, 0. So I can always put in a point in Desmos. I can come down here and say -3, 0, and it gives me that point. Okay, so I need to adjust now this number up here so that it goes through there, right? And again, I can adjust this because those aren't going to change from what I had it at, right? Okay, so see how this point is down here? Well, we know this needs to be reflected, so we change that to a negative, and then, oh, look, it goes through that point. Okay, so that's a way you can guess and check. All right, and then number 8. Okay, this one, both of them are in the bottom 2 quadrants, so that means I'm going to be dealing with this as its parent function. So this is where I'm going to start. Okay, so We come back over here and same thing. We start with the VA and the HA. VA goes through there. HA goes through there. Okay, so VA, X equals 0. HA, Y equals 0. Okay, so, oh, I forgot to do the domain and range over here. You should know it though. All reals, X cannot equal -4. Range, all reals, Y cannot equal 1. Okay, my apologies. And so since those two are 0, my equation, we start with that. Actually, this is going to be an A. And so now, like I know those two are 0, I just need to figure out the A value, right? So I start with my parent function. Okay, so here's my parent function. Y equals 1 divided by X squared. Okay, so again, it's up right now. I need it to go through the point now. I think it was -1, -4. Okay, I'm going to double check that. Yes. And so now I know that I need to reflect this. So I change that to a negative. It still doesn't go through that point. So I change this number. I start going and I say 2, nope, 3, nope, -4, yes. So now it went through that. So I'm just guessing and checking with Desmos. And so here's my equation. So the A value is -4. So I can erase this A value and I can substitute a -4 there. Okay. If I were doing this algebraically, remember, I can substitute that value. -4 is equal to the A value over -1 squared. And then technically, -1 squared is A divided by 1. A divided by 1 is just 1, so A is -4. So that's algebraically, right? And then the domain, all reals, X cannot equal 0. The range, however, goes from 0 to -infinity. So this is Y is less than 0. Or we can say -infinity to 0. As it goes from -infinity to 0. All right. And then we'll kind of do 7 and 9 at the same time. Okay, and I'm going to circle this value right there in both of them. Okay, remember what I said earlier, anytime we have an error or undefined, this tells me my VA. Okay, so it tells me my VA. So my VA is X equals 2 for number 7, and my VA is X equals -2 for number 9. So if it says undefined or error, that's my VA. Okay, now the HA is kind of what I want to try to find next, right? It's easy to see this in number 9. So I look at my Y values and I say, okay, this was at 13, then 11.5, 11, 10.75, 10.6, 10.5. So we look at and see what number does this approach, right? Right here, it's approaching 10, okay? And so we have Y equals 10 as our HA up here. This one's a little bit harder. We have numbers to both sides of the VA. So we go, okay, -2, -1, -2/3. I'm not sure really. 2, 1, not sure. This is probably 2/3. So in both directions, it kind of looks like it's getting smaller, closer and closer to 0. And some of you guys will understand that, and some of you guys are not understanding that right now. No big deal, because I'm fixing to show you guys VA and HA based off of these points. So if I want to figure this out, I can just plot these points. Okay, so if I go to Desmos, let's clear all this stuff. Okay, and I just start entering in points. And I put in the points that it gives me, right? So -1, -2 divided by 3. and then I do 0, comma, -1, 1, comma, -2, and then I have 3, comma, 2, and 4, comma, 1. Okay, so if I put in these points, I can hopefully see, right? Let me get rid of this. I can kind of see like this is part of a curve, that's part of a curve, but I know my X or my VA, right? We talked about how to find that really quick, and that was at 2. So now if we kind of look and we say, okay, if this was a curve, it would probably level out right here at y equals 0. Okay, and so that looks about right. Okay, so that's one way you can do that. If you can't see the HA, just plug these into Desmos and then adjust your VA and HA based off of those points, right? But again, the VA should be easy to see. So now, again, I have my equation, y equals a over x. This is a 2, so it's -2. And then plus 0, I don't need to write anything out there. So right now, this is my equation. I need to figure out the a value. So again, we can do that algebraically. We can say, we can pick any point. I'll pick that point. We can say -2 is equal to a over 1 minus 2. -2 is equal to a over -1. We can multiply by a -1, and we get 2 is equal to a. So the a value should be 2. Algebraically, right? That's how I did it algebraically. If you're unsure how to do that, again, all we got to do is guess and check. We already know that we have y equals, and we start with the parent function, right? And we adjust. We already know that should be -2. We're really close. We know that all we need to adjust is the a value now. And so I just say, okay, that's 1. I go up to the next one, 2, and there it is. It matches up all my points. And so that's my a value. So I can always guess and check, right? And so then coming down here to number 9, again, if I have the equation, y equals a over x minus a -2 is a +2, and then +10. So I know that should be my equation. We're just going to guess and check here. But again, I got to enter in all these points. So again, I come to Desmos. This time, I'm just going to clear all these points. I'm going to put in my new points. -1, 13, 0, 11.5, 1, 11, 2, 10.75, 3, 10.6, and then 4, 10.5. Okay. And so this one is a little bit, I say different, because again, we have the VA and we have the HA now. We know that this is 10 for sure. Okay. And so now I only have one side of it. So I adjust my equation here. This is a +2 now, right? And then I know I have +10 out here. So I'll zoom in a little bit. So I only have one side of my equation, but that's fine. I just need to figure out what the a value is going to be. So I just guess and check. I change 1 to a 2. Doesn't work. I change it to a 3. It works. I'm done. That's my equation now. Y equals 3 divided by the quantity of x plus 2, and then plus 10. So I know the a value here has to be 3. So I put in 3 there. And then my domain, all reals, x cannot equal -2. Range, all reals, y cannot equal 10. Okay. 3 more questions and then we're done. So it says given, so number 10 here, given this equation, what is the equation after the graph has been reflected over the y-axis, shifted left 2 and down 5? So here's a little bit different. So I'm starting with this equation. Okay. And I know from here I have to adjust different things. So the first thing is reflected over the y-axis. So reflected over the y-axis means I have a negative down here with the b value. Then right here, this means shifted left 2. So right here, x minus 1 means it shifted right 1 unit. Okay, so if I have to shift left 2 units, so we're at positive 1 and we go back to negative 1, so this has to change to a plus 1. Okay, does that make sense? So we were at x minus 1, which means I went right 1. We want to go left 2. So essentially, I just combined those two numbers. So that became a plus 1. And I do the same thing with down 5. Right now, we're at a negative 2. Down 5 more means that now I'm at a negative 7, right? So again, so down 2 is where I was. I go down 5 more. I combine those two numbers, and that gives me at a negative 7. Okay, so again, I started from the equation it gave me. Number 11, we get the VA and the HA. This is what we've been talking about. The VA is just the C value. The HA is just the D value. So I can write an equation, y equals A over x minus C plus D. So I take away C and I put in a negative 2. So x minus a negative 2 becomes a plus 2. And then I erase the D value. It's a positive 4, so I leave it as a positive 4. Since we don't have a point to plug in, then we'll just assume the A value is a 1. And that's my final equation for the HA of those two. And then right here, it gives me a domain and range. It's written a little differently. So I'm going to rewrite this. So where it splits it up right here and it says our domain goes from negative infinity to 0 and from 0 to positive infinity. This is the same thing as saying all real numbers with the exception of 0. The range kind of looks the exact same. This is all real numbers with the exception of 3. So hopefully you guys see that those two can be rewritten how we have seen it in the past. So what does that mean for us? Well, here is my VA again, and here is my HA. So y equals, we're going to assume A is 1, x minus C plus D, right? And so now I just have to fill in. The VA is 0, so do I really have to put in a 0? No. So that means I can kind of erase this stuff right here. So it's just x there. And then the y value is 3, so I put a 3 out here. And that's my equation.